IoT requires a constant and reliable power source to operate devices, sensors, and communication efficiently. The choice of power sources from IoT devices is from traditional batteries to cutting-edge energy harvesting technologies. The factors influencing the choice are device size, working environment, intended operation, lifetime of the device, operation reliability and availability. The majority of IoT devices use a DC power source. AC is usually converted into DC and eventually used to power high-power actuators. A general diagram of the IoT device powering solution is presented in this figure. Note that the internal energy storage system is usually a rechargeable battery, which is managed with a battery management system. Energy conversion units such as AC to DC or DC to DC converters are commonly used. The IoT node usually has the ability to monitor the energy consumption process and, commonly, also estimate remaining capacity, check the battery condition, and control the charging and recharging process. Most IoT devices rely on batteries as their energy source, which is common in edge-class devices. Fog devices are powered by various sources, a battery with DC or a grid with AC. Green energy sources are introduced in both classes. The choice of technology depends on the IoT application domain and scenario. Batteries are either non-rechargeable or rechargeable. They provide DC. A plain battery's voltage, example 1.5 volt or 3.7 volt, is usually unsuitable for directly powering the devices. The raw battery changes its voltage over time as the discharge process occurs. For those reasons, converters and stabilizers are used. In the case of modern rechargeable batteries, a charging and discharging module, so-called battery management, is also necessary to prevent overcharging or overdraining. Using green energy sources requires conversion and energy storage as their nature is non-consistent in the time domain. Using green energy as a power source requires a different approach to IoT device control algorithms because of the unpredictable nature of the green energy sources. It is common for devices to put themselves into the low power consumption mode on demand because of the sudden lack of energy. IoT edge-class nodes use energy harvesting models to grab energy from sustainable resources. In constrained, low-powered edge-class devices, light energy or vibration is common to power and charge the internal battery. The majority of IoT devices require 1 or 2 voltage standards to power microcontrollers and sensors. 5 volt, common for older microcontrollers such as AVR, and for most peripherals. 3.3 volt, for recent microcontrollers, more and more peripherals are 3.3 volt powered. During their operation, IoT devices commonly control their power sources regarding their condition to know the remaining energy and detect aging symptoms. In the simplest case, the battery terminal can be connected to the AD-GPIO, usually via a voltage divider. It's also expected to measure battery drain constantly, monitoring current and voltage, thus calculating energy consumed. Battery management systems can be a standalone module or can be a part of the IoT device. In the first case, using some communication protocols to monitor power source status is required, example serial or I2C. IoT devices can then inform the IoT ecosystem about, example, approaching running out of power. They can also limit their energy consumption by switching to sleep mode.